Question number 23. Given f, which is expressed as cos x for x positive number including 0, or ax plus b for x less than 0. So this is our function. Find the value of a and b such that the derivative at 0 exists. Okay, so f derivative at 0 exists የሚያደርገው a እና b ምን ቢሆኑ ነው ጥያቄው። So here we need to understand derivative in different ways, geometrically and algebraically. So the derivative at a certain point refers to the slope. Okay, a slope ማለት ነው, slope at 0 ማለት ነው geometrically, or you can say that the instantaneous rate of change at 0 ማለት ነው. Okay, so this is our function f of x. F of x is cos x for x positive number, and ax plus b will be used for x negative number. ይሄ ነው functionation. So its derivative becomes cos x derivative means minus sin x. This works for x positive number, and the derivative of x plus b will be a for x negative number. Okay, derivative of linear constant alone. Okay, so this is our f derivative. So f derivative at 0 exists, or the slope of the given function exists at 0, or the instantaneous change at 0 exists if the limit of f prime at x as x approaches to 0 is the same as f of 0. Okay, this means the limit of minus sin x as x approaches to 0 is the same as f of 0. Okay, so ይሄ ምንድነው የሚሆነው ማለት ነው? In this case, our f of 0 is already 0, or this limit is 0, so it has to be the same as a, okay, which is 0. Therefore this part is 0, therefore a will be 0, and b can be anything. B can be any real number. Okay, so the value of a is 0 and b is any real number, so that f derivative at 0 exists. Similarly, we go to the 24. For question number 24, we have the function f of x. The function f of x is given, which is x cube if x is negative, less than 1, or quadratic x squared plus bx plus c for x greater than or equals to 1. So this is our function. So its derivative, its first derivative will looks like z first derivative 3x squared nominal. This works for x less than 1, and the derivative of quadratic is 2ax plus b for x greater than or equals to 1. Its second derivative, the second derivative of this function will be 6x for x less than 1, and 2a for x greater than or equals to 1. This is the second derivative. The question is find the value of a and b where the second derivative at 1 exists. The second derivative at 1 exists implies the limit of the second derivative at x as x approaches to 1 must be the same as the second derivative at 1. Okay, so this means the second derivative as x approaches to 1 is used 1 and እናስገባለን. 6 is equals to 2a. This implies a becomes 3. So there is no restriction for b and c. B and c can be any real number. B and C can be any real number, but A is 3, the rest are real number. Number 25, find the third derivatives of the following functions. So for these functions, here we will see how the third derivatives can be obtained. So the function for a part, it's f of x is equals to x squared times e to the power of minus 3x. Okay, to find the third derivative, we begin by calculating the first derivative. So to calculate the first derivative for this function, we apply product rule for differentiation. So when we apply product rule for this part, we obtain f derivative at x is equals to x squared derivative times e to the power of minus 3x plus x squared times e to the power of minus 3x derivative. Okay, so this becomes 2x times e to the power of minus 3x minus 3x squared e to the power of minus 3x, or shortly it's good to write in this form, 2x minus 3x squared times e to the power of minus 3x. Okay, this is the first derivative. So let us again calculate the second derivative. So the second derivative of the function can be obtained by differentiating the first derivative, which is 2x minus 3x squared times e to the power of minus 3x. We apply here a product rule. So this means 2x minus 3x squared derivative times e to the power of minus 3x plus 2x minus 3x squared times the derivative of e to the power of minus 3x. This result becomes 2 minus 6x times e to the power of minus 3x plus take the derivative of e to the power of minus 3x, which is minus 3 times e to the power of x. The result is minus 6x plus 9x squared times e to the power of minus 3x. So we can collect like terms and write this like 2 minus 12x plus 9x squared times e to the power of minus 3x is our second derivative. This is the second derivative. Okay, so our second derivative is this one. So now the question is third derivative. So the third derivative of this function will be obtained by differentiating the second derivative. So it becomes 2 minus 12x plus 9x squared times e to the power of minus 3x. Okay, here we apply product rule for differentiation. So product rule ስንጠቀም ምንድነው የምናገኘው? 2 minus 12x plus 9x squared derivative times e to the power of minus 3x plus 2 minus 12x plus 9x squared times the derivative of e to the power of minus 3x. Okay, so ይሄ ምን ይሆናል ማለት ነው? minus 12 plus 18x times e to the power of minus 3x. Okay, plus this becomes minus 6 plus 36x minus 27x squared times e to the power of minus 3x. Okay, now collecting like terms, the third derivative becomes, when we collect like terms, the third derivative becomes minus 18 plus 54x 54x minus 27x squared times e to the power of minus 3x. This is the required third derivative for the function in a part. When we come to the b part, the function is f of x is equals to ln 5x. This is a composition of linear and logarithm. So the first derivative can be obtained by using chain rule. So apply chain rule to calculate the first derivative. So it becomes ln 5x derivative over ln 5x. Okay, when we apply chain rule, we get this thing. So the result is 1 over x ln 5x. This is the first derivative for the given function. 1 over x ln 5x is the first derivative. So to calculate the second derivative, the second derivative of this function will be obtained by taking the first derivative, which is 1 over x ln 5x. Okay, this derivative requires both quotient rule and chain rule. So quotient rule or chain rule ተጠቅመን የዚህን derivative እንሰራለን. So it becomes 1 derivative times x ln 5x minus 1 times the derivative of x ln 5x over the square of x ln 5x. Okay, we square it. Okay, so we apply the chain rule. So we apply the chain rule. Unfortunately, this term one derivative is 0, therefore this term becomes 0, and we apply product rule and chain rule in this part. So the result becomes here, the result becomes the negative of ln 5x plus 1 over x ln 5x the whole square. This is our second derivative. Okay, this is our second derivative. I'm just jumping few more steps. So minus of ln 5x plus 1 over x ln 5x the whole square is the second derivative. So the third derivative will be obtained by taking the differentiations on the third derivative will be obtained by taking the derivative of the second order derivatives. So minus ln 5x plus 1 over x squared ln 5x squared. Okay, we take the derivative of this part to obtain the third order derivatives. So apply both chain rule and quotient rule on this expression. So the third derivative, you will get the third derivative, this one. The third derivative becomes 2 times ln 5x plus 1 minus ln 5x over x ln 5x the whole cube. This is the more simplified form of the third order derivative for the given function. Okay, now when we come to the c part, in c part our function is f of x is equals to cos square x minus e to the power of tan x. Finding the third order derivative for this function is very boring and lengthy, so I prefer to give you this the answer only, because I don't have enough workspace to solve this one. So it's very simple to calculate the first derivative for this function. You can immediately obtain the first derivative, which is cos square x minus e to the power of tan x. The derivative of this one is automatic, and it will be minus 2 sin x cos x, minus 2 sin x cos x, minus sec square x e to the power of tan x. Okay, but 2 times sin x cos x means sin 2x. Okay, so minus sec square x is a power of tan x. This is only the first derivative. Okay, this is the first derivative. So the second derivative will be obtained from the first derivative. So I'm going to give you only the result because of lack of enough space to calculate here. So the second derivative becomes minus 2 times cos 2x minus sec square x is a power of tan x. Then in the bracket you will have 2 times tan x plus sec square x. It's good always to write the more simplified form. This is the more simplified form for the second derivative. So the third derivative will be obtained by differentiating the second derivative. So the result, I'm going to write only the result for the third order derivative so that you can compare your answer with my solution. So the third order derivative, I got this value for 4 times sin 2x minus in the bracket sec square x is a power of tan x, in the bracket 2 times tan x plus sec square x, okay, plus here plus sec square x is a power of tan x, in the bracket, in the smaller bracket 2 times sec square x plus 2 times sec square x tan x. Okay, so you can make it like this. You can further simplify this one. I think this can also be further simplified in some other form, but for now this is the third order derivative for the given function in C.